All right, hi everyone. So today we're going to work on logarithmic equations. So we're going to solve logarithmic equations, meaning that we're going to solve for a variable that happens to be in a logarithmic equation. So these are equations that involve logarithm and the variable is in the logarithm. Okay. I don't know what's going on here. All right, and the way we're going to do this is we're going to be using our properties and definitions. We're going to use the definition of logarithms and properties of logarithms. Okay, so we're going to use both those things to solve. All right, so the first group is using the definition, or what I call using the exponents. So by definition, what we're going to do is we're going to rewrite these problems as an exponent. So I'm going to look at the base, I'm going to write it as an exponent, and then I'm going to solve from there. All right, so if you notice, there's no base there. Remember, that's understood to be 10. So I'm going to write this as 10 squared equals 4x minus 3. Okay. So now this isn't too bad. I'm going to make this 100 equals 4x minus 3. Solve for x. So add the 3. Divide by 4. I'm going to get 25.75. And that's going to be our solution. All right, let's try this one. Again, you notice our base is 10. Doesn't always have to be 10, just happens to be 10 in this particular problems. So 10 to negative 1 is equal to 3 minus 2x. All right, so remember 10 to negative 1 in decimal form is 0.1, in fraction point is 1 over 10. I'm going to use the decimal form. So 0.1 is equal to 3 minus 2x. I'm going to subtract the 3. All right, so I'm going to subtract the 3, and that's going to make me negative 2.9 is equal to negative 2x. Let's divide by negative 2, and I'm going to get 1.45. Okay. All right, let's try one more of these. Again, our base is 10. Don't just assume that the base is always going to be 10. Okay, so look for your base and then write it as an exponent. So 10 to the 8th. Ooh, before we do that, I was mistaken. See the plus 4? We're going to have to subtract that 4 first. I apologize. Let's get rid of that 4 first. So log x is equal to 4. So I'm going to make this 10 to the 4th is equal to x. That makes it a lot easier if I get rid of that 4. And then that gives me 10,000. And that's our solution. So again, use your definition by taking the base to the other side of the equal sign and making sure that your logarithm is by itself or isolated before you start. The next ones are using the properties. So if you remember, addition means to multiply, subtraction means to divide, and a power out in front means it becomes an exponent. So then what we're going to do is from there, we're going to write it as an exponent problem like we did in the previous problems. All right, so let's take a look at this one. If you notice, it says addition, which means that I'm going to rewrite this as a multiplication problem. So log, and again, it's common log, base 10. 10 minus x minus 3 times x is equal to 1. All right, so let's distribute that x. Let's write it as an exponent. And now it becomes a quadratic, so now I'm going to have to solve a quadratic. So remember 10 to the first is 10. So I'm going to move that over to the other side. Okay, so now I'm going to have to factor. So factors in negative 10 to add to negative 3. Let's use negative 5 and 2. Which means I'm going to have to set both of those equal to 0. So I'm going to get answers of 5 and negative 2. Now the question is, are both solutions to the original problem? Fortunately, I don't think so. So let's put them back in. So I'm going to put 5 in. So we're going to do, here's our check. Let's call this the check. So the original problem was log, it would be 5 minus 3 plus log 5, and is the answer equal to 1? So log 2 plus log 5 is equal to 1, and I can just use my calculator if I wanted to. And we do get 1. So 5 works. We're good to go. So let's try negative 2. Okay, if you put that in your calculator, you're going to get an error message. Okay, so this has no solution. This is an extraneous root. So our only solution is 5. 2 does not, negative 2 does not work. And we should always check our solutions for these because they don't always work, especially when you're solving the quadratic. All right, let's try this one. All right, so this is subtraction, which means that I'm going to divide. So log x over 2 is equal to 3. All right, now I'm going to write this as an exponent. Okay, so that's 1,000. Equal to x over 2, multiply both sides by 2, we get 2,000. It's equal to x. Again, we should check our work. So log of 2,000 minus log 2 is equal to 3. All right, so just use your calculator. Log 2,000. Make sure you put parentheses, minus log 2. And I do get 3. So 3 is equal to 3. Kaboom, we're good to go. So 2,000 is our correct solution. All right, so let's try these 2 more, okay? All right, so subtraction means division. Write it as an exponent. Okay, I'm going to write this one as 1 over 100. Because now I get 2 fractions that are equal to each other, which to me screams cross product. So when I do cross product here, I'm going to get 3x is equal to 600. X is equal to 200. So 200 does work. We do get negative 2. So I'm giving you a heads up there. That does work. All right. Let's try this last one. Oh, what's happening here with my log and bill? Oh, this is a problem. Because I have log on one side and then I have a log on the other. So this guy right here, here's my suggestion. That we take this log right here, this guy, and bring him over to the other side to make him a subtraction problem. So let's make this log of 7x plus 1 minus log of x minus 2 is equal to 1. All right, so subtraction means division. So log of 7x plus 1 all over x minus 2 is equal to 1. So write it as an exponent. And again, anytime I have a fraction, I'm going to write this as a cross product problem. It's just how I find it easier to kind of work with. Again, it's just the way I solve things. Now I'm going to distribute and solve. So I got x equals 7, and again, you want to put it in to double check. Always go back to the original problem to do that. So that's 49, so log of 50 is equal to log of 5 plus 1. And we do get that to work. So let's double check. Log 50. And then, yep, it works. Okay, so our answer here is 7. All right, so take a minute, pause the video. I have more practice for us, and see if you get the same answers as I do. All right, so down here I have more practice. Okay, these 4 problems. So the first ones were not too bad. I just wrote them as exponents, and then the next group I did the properties. Okay. Let me know if you have any questions, guys. And remember, staying in is meaning that we're going to stay safe and keep each other safe. So I'll talk to you again soon.